Hi, in this video today, we're going to talk about some example of how to do implicit differentiation. Suppose I have, example 1, suppose I have x cubed plus y cubed equal 64. Okay. The first step, what I would do is I'm going to differentiate both sides with respect to x. So d dx, d dx. On the right-hand side, the derivative with respect to x of a constant is 0, right? This doesn't change. On the left-hand side, the derivative, the derivative of the sum is the same thing as the sum of the derivative. So this becomes the derivative with respect to x of x cubed plus the derivative with respect to x of y cubed. The derivative with respect to x of x cubed is just 3x squared. Right? However, the derivative with respect to x of y cubed, we need to apply change rule here, right? So first, we take the derivative with respect to y of y cubed, and then multiply it with the derivative of y with respect to x. Because here, y is a function of x, right? So whenever you do implicit differentiation, if you take the derivative with respect to x of a y term, you always add dy dx in it. Okay? Or if you don't want to write dy dx, you can always write y prime. Okay, you can substitute dy dx with y prime. All right. So now 3x squared is 3x squared. The derivative with respect to y of y cubed is 3y squared times dy dx equals 0. I want to isolate dy dx. I want to isolate this term here. So I'm going to subtract 3x squared both sides. So now I have 3y squared times dy dx equal to 3x squared, negative 3x squared. And now I'm going to divide both sides by 3y squared. So that I have the left-hand side is just dy dx equal, the right-hand side is reduced to negative x squared equal y squared. So that's the answer of our first example. Example number 2, suppose I have e to the xy plus x squared minus y squared equal 10. Again, the first step is that I would take the derivative with respect to x, both sides. So this is d dx, d dx. Again, on the right-hand side, the derivative with respect to x of a constant is 0. On the left-hand side, we're going to break it down into the derivative with respect to x of e to the xy plus the derivative with respect to x of x squared minus the derivative with respect to x of y squared. Okay. Now again, whenever you take the derivative with respect to x of a term that have y in it, we need to use change rule, right? So for the first term, the derivative with respect to x of e to the xy is e to the xy times the derivative of the inside, which is xy prime, right? Actually, let me use this notation, d dx xy. You can use that notation, right? Or you can use xy prime plus plus the derivative with respect to x of x squared, that's just 2x, and the derivative with respect to x of y squared is 2y times dy dx equals 0. Well, the first term is kind of messy, this one right here. So we're going to do it slowly. So let me rewrite e to the xy times, now the derivative with respect to x of xy, here we're going to apply, this one right here, we're going to apply product rule, right? So if you take the derivative of two functions, fy, right, fg is equal to f prime g plus g prime f. Right? Here you can think of f as being x, and y is being, g is being y. Okay. So first we're going to take the derivative with respect to x of x, that's just 1, right? That's just 1. That's just 1. Times g, which is y, times y, plus g prime, which is derivative with respect to x of y, is the derivative with derivative of y with respect to y is 1 times the derivative with respect to x, to y of derivative with respect to y of x. Times x times f, and plus 2x minus 2y times dy dx equal to 0. Okay, so now I'm going to distribute this term. So I have e to the xy times y plus e to the xy times dy dx times x plus 2x minus 2y times dy dx equals 0. Okay. Now again, I want to isolate dy dx, right? So I'm going to group the term that have dy dx in it. So I'm going to group these two guys. And then the term that doesn't have dy dx in it, I'm going to move to the right-hand side. So let's move them to the right-hand side first. So I'm going to move, I'm going to subtract 2x both sides so that I have negative 2x. And then I'm going to subtract e to the xy times y so that I have negative e to the xy times y here on the right-hand side, right? For the left-hand side, I'm going to factor out dy dx between these two terms. Okay. So dy dx, and then for the first term, I have e to the xy times x minus 2y equal the right-hand side, right? And now because I want to isolate dy dx, so I'm going to divide both sides by e to the xy times x minus 2y, e to the xy times x minus 2y. Okay? So this one cancel, which is left me dy dx like I want it. Right? And for the right-hand side, that will be equal to negative 2x minus e to the xy times y divided by e to the xy times x minus 2y. Okay, and that will be complete our answer.